Hello and welcome to our tutorial on how to find, read and manage academic literature. While this title is pretty self-explanatory already, let's take a quick look at what we are going to cover in this tutorial. First of all, we're going to show you how to find relevant literature for your project, which tools to use and how to use them in the best way, in the most efficient way. Secondly, we are going to show you how you can read the papers that you discover most efficiently so that you save time. We're also going to show you how you should cite the related work that you discover according to academic principles that are valid particularly in computer science. Eventually, we're going to show you how you can manage all the literature, all the sources that you gather for different projects in a consistent way so that you can reuse them, for example, for future projects or also share them with other people. Everything we're going to cover today are essential skills for different parts of your study. They are particularly relevant for the seminar, when you need to write a seminar paper, which is typically a literature review, or also for a practical project when you have to write a project report. Most importantly, of course, they are relevant for any kind of thesis that you have to write during your studies, be it a bachelor, a master, or even a PhD thesis. So, let's dive right into the first section, which is how to find relevant academic literature. All of you, I'm sure, are familiar with web search engines. All of you have used them, are aware that they are keyword-based search engines, so you enter keywords, you get a result list, and so on. All of you have used Google. Maybe not all of you are aware that there are specialized search engines, so-called academic search engines, that focus on academic literature. We are going to show you some of them that we think are particularly useful and you can use for your literature research. Academic search engines can be broadly divided into two classes. So you have free search engines and commercial search engines. Two of the very useful free academic search engines, in our opinion, are Google Scholar and Semantic Scholar. Google Scholar, as the name suggests, works very similarly to the Google Web Search Engine. So it has this more or less the same interface, just a search box, you type in your keywords and you get a result list that has only a couple of additional features for filtering and narrowing down your search, which we will look at in a bit. Semantic Scholar offers a few more features, also features that Google Scholar does not offer, such as author network analysis, for example. But at their core, all these search engines work very similarly, so they are typically keyword-based search engines that look for academic literature, present you at their core, at their main functionality with a result list, as you see it as a snippet here for Semantic Scholar. So you get a result list where you may or may not have access to the full text and some additional information like citation counts and so on. The benefit of these free engines, these two free engines that we are showing you right now, aside from being free, is that they have a very large coverage. This large coverage results from their conceptual approach. Like Google does with web pages, these two engines also crawl the web or crawl open access repositories of academic literature for papers and process these automatically to index them and make them searchable. This has, as I said, the advantage of providing access to a very large number of papers. On the other hand, of course, it requires a lot of automated processing because this is not the core business, for example, of Google, and the Google Scholar team is rather small. So that not a lot of manually curation can go into this process. So it relies on automatic procedures and therefore results in a comparably lower quality, lower data quality than for example, more manually curated collections, which are typical for commercial search engines. So two very well-known and also very powerful commercial academic search engines are, for example, Elsevier Scopus and ISI Web of Knowledge. For those commercial products, more effort can be invested into data quality because you pay a subscription fee, which then results, unsurprisingly, in cleaner bibliographic metadata as you typically find them in the two free academic search engines that I just showed you. Also, these commercial search engines typically offer additional features such as quality rankings for journals or also conferences. On the downside, of course, they require a subscription, which is typically quite expensive. I don't think it helps you a lot when I show you all these different engines here. So I would suggest take a look at all of them if you have access. So check whether you have access to Scopus or to Web of Knowledge. You for sure will have access to Google Scholar and Semantic Scholar. Just check them out. You will see they are very similar in their core functionality, author profile pages, keyword-based search, ranked result lists. Play around with them and find the one that suits your needs the best. When you actually decided on one and go on to searching for literature for your project, of course, the key is in finding the right search terms for your topic. That sounds simple, but turns out to be often harder than one would expect. Why is that? Well, the terms to describe your interest or describe your problem may or may not be what you think they are. Yeah? So we really suggest that you find and read a couple of exemplary papers that you are sure treat the problem that you're interested in, to look for the exact terminology that you actually need to describe your problem. Also check the cited papers. So the exemplary papers that you found in the first step have cited. Why? Because often the terminology in a certain research field changes over time. So the problem might have been referred to in a different way 20 years ago than it is now. Once you've found your initial set of search terms, try to experiment a little bit with them. For example, find synonyms and query them too. To expand or also to narrow down your search, many academic search engines offer search operators. This could be Boolean operators like and or to combine search terms, or also like similar operators. For example, the tilde operator that lets you search for synonyms in some search engines. If you are looking for very exact matches, for example, phrases of several search terms, you should enclose them into quotation marks, because this tells the search engine that you're looking for a phrase that consists of these 2, 3, or 4 search terms, and you don't want to start an or search for these terms, but you want to find exactly this phrase. Very useful, and all the search engines that we showed you offers this functionality are additional features for filtering or expanding your search, such as citation counts, for example. Yeah, so what you see here on the right is actually the panel that Google Scholar offers you to narrow down your search or to also sort your search results the way you want them. Yeah. So you could, for example, filter to a certain time area, or sort them by relevance, by citation count, or also just by date. Why is that interesting? Well, if you want to find more recent papers, this makes of course sense to sort them in reverse chronological order. Also, highly cited papers, that's why this information on citation counts is so important, are typically highly qualitative paper, very authoritative papers. Some of these academic search engines that we showed you also allow you to save and export your search results or browse through author profile pages that show, for example, all the publications of an author that this particular search engine is aware of. One thing that we should mention is at their very core, these are search engines. So it's not guaranteed that you actually get access to the full text from this search engine. Yeah. Typically, particularly the free engines like Google Scholar and Semantic Scholar, they try to find and link a full text for you, but it's not clear from where this full text for the source that you just discovered comes from. In fact, these search engines link to very different sources. So it might be that they find the publisher page, as in this case for ACM, IEEE, Springer, for a publication, but it might also be that they find some other source like an author website or an institutional repository. So you have to pay attention which version of a publication a search engine actually discovers and whether you would like to accept this version as an authoritative source. I already mentioned some of the other sources that you might discover in the result lists of academic search engines. For example, preprint repositories such as arXiv, which you see also in the picture here, or another very large one is core.ac.uk. It's a repository that focuses on finding open access publications and providing them again as a search engine or via a search interface. Zenodo.org is also a very large open data repository, not just for publications, but also for data sets, code, and so on. Another very valuable source for finding full text for academic publications are social networking sites for researchers, such as ResearchGate, which is the largest of such sites, or academia.edu. Yeah, so they typically also have author pages with all the publications that the search engine found or that the author entered, and that is different from pure search engines, academic search engines, that they allow authors to upload full texts to their profile pages so that you can then access them regardless of whether you may or may not have access via the original publisher site. Last but not least, there are institutional repositories, so from universities, for example, like here, the ETH Zurich, or also just personal author web pages where researchers may upload the full text of their publications if the publisher, such as IEEE, ACM, and so on, does not provide them open access. So yeah, check which sources academic search engines link, and if you don't have access to a full text via the publisher site, try to obtain the full text from one of those sources that we just listed here. Let's assume you found the full text for a publication or also for a base set of publications, but you want to find more related work on that topic that you just discovered the base set of papers for. Yeah? So what could you do? What are good strategies to find more related work on a topic? Well, one very successful approach is to just check the authors and what else they published. So typically, authors stay in a certain topical area and publish in that area. Yeah? So you may identify the authors, find their personal web pages or also their institutional repositories, and just check, what else did they publish? Maybe you just start from their profile page within the academic search engine right away. Another good approach is to check a certain venue. So when you found papers that are very relevant to your problem, you may check where they have been published. So at a certain conference or in a certain journal, and whether this conference or journal actually is very characteristic of the topic and problem you're looking at. Yeah? When this is the case, you find out it's the case from looking at other papers in this conference or in this journal, try to find, other proceedings. Proceedings are the published result of academic conferences or other recent issues of this journal, and check whether these papers in these issues or in these proceedings are also relevant to your topic or problem. What you should be aware of is that not all journals are actually qualitative journals, although they may look like this. Yeah, so there's quite a number of journals out there that have not a good reputation. In fact, they have no scientific quality insurance, such as peer review, and they are just there so that authors who have to publish, for example, to get a degree, many institutions require PhD students to publish a certain number of papers. So if authors have to publish, these, what we call fake or predatory journals, offer the authors the option to publish, at least apparently, publish their paper without performing any quality assurance, and the author has to pay for it. So these fake or predatory journals, they may actually look like just perfectly fine qualitative journals, but they are not. So it's not always easy to discover them, but there is a nice project, a list by a researcher, which is Beal, that's why it's called Beal's list, that lists all the predatory, so low quality journals that this researcher found. And you may check it if you have doubts about a certain journal, whether you actually want to look at articles from that journal or even cite it. As we already discussed for the academic search engines, references and citations are very valuable features in academia and in academic literature search to dig deeper into a topic. How exactly? Well, if you check the references, so the sources that the papers you discovered are relevant for your topic cite, you automatically get to papers that are prior to the paper you are looking at, and probably address the same or very similar problem. So if you want to find earlier work to the paper that you already found, just check the references for papers that have been cited. Also, this typically indicates a certain quality assessment, because authors typically do not cite papers that they find are of low quality, but they typically cite them because they found them valuable or beneficial. Yeah? So by following the papers that another paper cites, you go back in time, also maybe in multiple steps back in time, and can explore a topical area better. The same goes into the other direction. So if you want to find more recent works, you should make use of this feature of academic search engines, that they often show you which other papers cite the paper that you are just looking at. As I said, again, this is a very important quality metric, quality assessment. Highly cited papers are typically high quality papers, very relevant papers, very authoritative papers. So if you find papers that are highly relevant for your topic and highly cited, this is a very good sign. And also by following the citation links, so finding papers that were published after the paper you are just looking at, you find more recent work referring to your paper in the same area. Okay? Good. Please try and play around with these search engines and search approaches to actually find the base set of papers for your project, so your related work. Assuming you have done that, and quite often you retrieve a significant number of papers this way, the task comes down to, okay, now I need to read and understand these papers. And in this section of the tutorial, we are going to show you some best practice approaches, how to do that in the most efficient way. Probably most of you have already seen a scientific paper, and maybe you have also noticed that most scientific papers follow a certain common structure, a common outline. Yeah. You could also say it's sort of an expected structure in academia, or particularly in the technical sciences. The exact structure differs a little bit on the field, sometimes also on the venue, so the journal or conference where a paper is published. But in general, it typically comes down to a structure similar to this. So a paper typically has an abstract that summarizes the main points, the main contributions, the main findings of a paper, alongside, of course, a very quick introduction into the problem that is actually addressed and maybe the results that were achieved. This is followed by an introduction, a related work or state of the art that may or may not be the third item in this structure. Some papers also move it to the very back to not get in between the problem and the proposed solution or the proposed study of this problem in this paper. But it's typically somewhere, so either at this third spot in the structure or at the very back. Then there is typically some sort of description how this paper, how the study that it reports on has been conducted. There are some evaluation or quantitative analysis or also qualitative analysis, including results which need to be presented. And eventually the paper is finished off with a discussion, a conclusion, and very often a future work section. If you're not super familiar with this structure, so if you're not very clear which part of a paper goes where, we'll provide you a handout together with this video that you can check out, and you will see where certain content typically goes in scientific papers. How does that help you? Well, once you internalized this typical structure of a scientific paper, it makes it very easy for you to jump at the right place in a paper if you are looking for a particular piece of information. Yeah? So please study this if you're not familiar with the typical structure, to know by heart where you need to look and quickly be able to go there if you're looking for a particular piece of information. So, Assuming you're aware of the structure, there are still tips that increase your speed in reading academic papers. What will follow is a 4-step approach to reading academic papers that is sort of a best practice guideline derived from our experience, but also the experience of other authors, such as Keshor, which also wrote a paper on this, a short paper on this. You may check it out. His approach only included 3 steps, so we adapted it a little bit because we thought another preliminary filter step is more appropriate, particularly for students. How to understand it is these sequential steps are essentially filters. So don't feel compelled to performing all of them. On the contrary, your goal should be that for many papers, you don't perform them all, but that you filter out papers after one step or the other that are not as relevant or not relevant enough for your topic or problem that you want to read them in full. So basically, we want to show you techniques to get the most important information out of papers quickly so that you can decide whether you actually want to go on and read all the paper or not. This process starts with a step that is very quick, and we call it first impression. Yeah, so it should take you just 1 to 2 minutes, and the goal is to decide if this paper that you just discovered, for example, with an academic search engine, might be relevant, you're not sure yet, might be relevant for your topic or problem at all. So what should you do to decide that? You should A, read the title carefully. You should browse, and browse does not mean read, but really browse, glimpse over it, the abstract. And based on these 2 pieces of information, decide what is likely the research question that this paper investigates, and is it related, relevant enough to my problem that I want to go on with processing this paper. If you decide yes, that's the case, you should go into step 2. You should follow up with step 2, which we call the bird's eye view. This processing step should take you between 15 to 20 minutes, depending on how long the paper is and also how versed you are in reading papers this way. The goal of this step is, again, making a decision, namely the decision whether after doing this step you feel the paper is still relevant enough to actually warrant reading it completely. Yeah? So you're still, even in this step, not reading the paper completely. But you are taking in, of course, more information from the paper than in the first step. So what are you doing exactly? Now you carefully read the abstract. So the abstract is, as I said, a synopsis, a boiled down essence of the paper. At least it should be if the paper is well written. So it should give you a lot of very valuable information that helps you to make this decision already. Then you skim through the paper and only read the section and subsection headings to get an idea of the structure of the paper. Yeah? Does it follow this typical structure, or is there something different? If there is something different, there's typically a good reason for it. So read just the headings, nothing else, just the headings. If there is a section that says something about specific research contributions, then it's worth to browse over it. Still not reading in detail, but just taking a quick look to get an idea of how they analyzed the problem and what their research contributions are. Yeah. Same for the methods. Yeah, so read both what the authors claim are their contributions and sort of browse glimpse over the section that says how they achieved these contributions. Don't go into detail there, don't get bogged down. Just glimpse over it so you have a rough idea of what it probably will be. Then, again, read the conclusion completely, read them. Why? Because there is sort of an expected structure, particularly when you write in English, and most scientific papers are in English, that forms sort of a frame around the main content of the paper. So it starts with the introduction that frames the problem and ends with a conclusion that summarizes the paper and the contributions again. So this frame should give you a very good idea of what is happening in the paper, although you haven't read in detail yet what is happening in the paper. Yeah, so read the conclusions and also glance over the reference list of the paper. Why? Because ideally you will find references that you already read. And by seeing them again, you may be able to deduce that the paper you're looking at is in a certain, topical area, somehow related to other sources that you already know the content of, which again gives you a better idea of what is probably going on in the paper. If that's not the case and you're totally unfamiliar with all the references, that's also good, it's not wasted time, because then you can go back and decide whether you actually need to read those references. Yeah? So that's the second step. When you've done that in 15 to 20 minutes, you should be able to answer the so-called 5C questions. What are those questions? Well, first of all, what category of paper is this? So is it a literature review that just presents knowledge or presents findings that others achieved? Or is it an original paper, like a quantitative study of something, or an original paper that proposes a new method or a new system and so on? Yeah, so what type of paper is it? The context of the paper, that's what we just discussed by glancing at the references. So which other papers does this paper cite? What is it related to? Maybe which theoretical basis is it drawing on? Does it seem correct? So from taking a quick look at the methods section, do you think that the conclusions that are presented in the conclusion section can be achieved this way? Is it valid? You should be familiar already what the claimed contributions of the paper are. And from reading the abstract and the conclusion, you can also already get an idea whether the paper is well written or not. And also from the structure that you looked at, because if it has a completely confusing structure, chances are that this paper is just not well written. Based on this information, you need to make a decision whether this paper seems relevant enough, seems qualitative enough to warrant a full read, because this would be the third step. Really reading all the rest of the paper to grasping all the content that is in there in detail. Yeah? This will probably take you up to 1 hour. When you're not familiar with reading scientific papers, maybe even a bit more, but typically about 1 hour. And the goal is, yes, to understand the content that is in the paper. Yeah? How do you do that? Of course, you need to read the complete paper now, depending on when you exactly perform this step. So if you directly perform it after step 2, then you only need to read the parts of the paper that you haven't read yet. Still, while you're reading it, try not to get bogged down in details. Don't lose yourself in details. And typical traps where you can get lost are, for example, mathematical proofs or very complicated math that you need to follow. Try not to get too much into that, especially if you have trouble understanding it as of yet. Yeah? If you need to, there will be the fourth step where you can dive into this completely. For now, try to see whether it probably makes sense, whether it's probably valid, and if you have the impression, then try to go over it and understand the rest of the paper from the text. What helps you a lot to judge whether a paper is a good paper is to take a careful look at the figures, tables, and graphs in this paper. For example, if you look at the figures, you should ask yourself, are all these figures that are presented in the paper actually necessary, or may authors, you have the impression that authors inserted them because they needed to fill some space? Are all the figures large enough and high resolution enough to actually be readable? Are all the components that you see in the figures explained in the text? So can you actually understand the figure? Same for graphs. Are the results or the measurements presented in the graph actually suitable for whatever this paper wants to achieve? Are, for example, quantitative results shown with error bars when authors claim to achieve a certain statistically significant result? Are graph axes labeled? That's very important because otherwise it's sometimes hard to understand what they actually show. For tables, which are very common in computer science to present quantitative results, you should check whether there are typical measures used for this sort of study, whether the experimental parameters, for example, are stated clearly, under which circumstances the experiments were performed, and whether the results actually support the conclusions that you already read. Very important also, during this step, take notes, because you will forget. You will read other papers and you will forget. So take notes on key ideas, key arguments, important methodological decisions, and the contributions of the paper. Also, of course, if you discover them on flaws and unaddressed research questions, because this gives you a good idea of what you, for example, could work on. At the end of this step, again, check the references carefully, really check off, which ones you know, which ones you don't know, and particularly the set of those that you don't know yet, take them as input to this 4-step process again, and then check them according to steps 1 and 2, whether you should read them also. Once you're done with this 3rd step, you should be able to understand, most of the paper, like the content, the statement of the paper, the results of the paper, the methodology, and so on. You should be able to summarize the paper and also have supportive evidence ready to prove the summary that you do. For most of the papers, step 3 is the last step that you will perform. So particularly for a literature review, step 3 would be the last step, because after this step, you should understand the paper enough to be able to summarize it as part of your review. If you're not, then maybe you need to read on to actually get some background knowledge so that you can understand the paper, or maybe the paper is just bad and you discard it. Only if you really plan on extending the research in this paper, or if you're a PhD student and you need to review the paper for a conference, for example, then you should continue with step 4 and try to understand the details of the paper even better. Because sometimes you just don't achieve this goal of understanding the paper after step 3. Yeah? Typical causes could be, this subject matter is just too unfamiliar to you. Maybe the authors used a certain approach that you're unfamiliar with. Or the paper is just poorly written or bad. Maybe it's not a high quality paper. So what are your options if you discover that? Well, you can just discard the paper if that's okay for your project, or set it aside and come back to it later if you find out it might not be okay to just discard it, maybe if many other papers, for example, cite it. So return to the paper later, or really, if you think it is highly relevant, then go on with the 4th step and try to understand it anyway. In the 4th step, and again, this is typically not necessary. Not for a seminar paper, most likely, or just for very few papers in your thesis, this fourth step is necessary, namely if you want to extend them. It can be understood as a mental re-implementation of the paper. So sort of you imagine you would want to write this paper and you would do that. Would the paper look the same as you just read it, or would it be different, and why? This step, depending on how experienced you are with it, can take anywhere from 1 up to 5 hours. So yeah, make sure that this is really necessary for your case. Should you decide that it is, what you would do is you really try to understand every detail in this paper. You check the math, you check all other details, you identify and challenge every assumption, every claim that the authors make to check whether it's valid and justified. You think about how you would present, this argument, structure, the ideas in the paper, and whether it would look the same as the authors did, and if not, what this means. You also take notes for future work. So after this step, you should really be able to reconstruct the entire structure of the paper from your memory, by heart. You identify very clearly the strong and weak points of the paper, and you are able to argue on it. For example, as part of a paper review, particularly if there are any weak points, then you are able to pinpoint implicit assumptions, missing citations to related work, methodological issues, and so on. So basically flaws of the paper. Again, typically not necessary unless it's a super relevant paper for your specific research and you want to extend it or explain exactly where its flaws are, which you then address in your project. Okay, so much for reading, for the reading process that we suggest to follow to make reading academic papers more efficient. Very importantly, whenever you follow this process, take notes. So there is a nice saying that the faintest writing is better than the best memory. So take notes. Even if they are not perfect, they are better than not having them. Still, we would like to give you some best practice experiences for actually taking notes that hopefully are the most useful to you also over a longer time. How you manage your ideas and notes also depends on the type of reading you do. If you just try to stay up to date in a certain area, for example, machine learning, where new developments come in very fast, so you constantly need to read, even you may not have a specific project you're working on yet for which you, for example, want to find related work or the research gaps in existing work. You just read and want to keep notes of things that you read. Then the perfect tool for that would probably be reference managers, which we will show you in a bit. If you are already working on a specific project, such as a seminar paper, so a literature review, or your thesis, so you already know sort of the main points that you need to extract and present from papers, then more structured approaches and tools for taking notes are typically more useful, for example, such as mind maps. And two very good tools for keeping notes about academic papers in mind maps are, for example, Coggle, which is a free web-based mind mapping service. You can also share your mind maps with others. Or a web service, not a web service, but a service that our group actually developed is DocEar, which is a free desktop application that allows you to combine literature management and note-taking in the form of mind maps. So you are actually able to drag in, as you may see in this little screenshot already, your papers here, Document would automatically extract all the annotations that you made in these papers. Then you can, of course, also insert freely worded notes and arrange all of these content items, as you would like them in the structure that your mind map should have. Yeah. Mind maps sort of impose a certain way of organizing information. Yeah? So in these nodes that are hierarchically structured and so on, that not everybody likes too much. Some people just prefer nodes, just textual nodes, and to good applications to do that in still a structured way would, for example, be Evernote or Scrivener. So if you're more into just text and not so much into the graphical way of representing information that mind maps impose, then you may want to check out those. Okay, this concludes our section on reading and sort of understanding and keeping the information you read in academic papers. Let's now assume that you have found all the papers that are relevant to your topic. You have processed them according to the 4-step process that we presented, identified all the relevant papers, and found all the information you want to refer to, and you now actually want to use this related work as part of your paper or thesis. So you want to cite the related work. I think you all know that in academia you always have to cite any content, that is any material, words or ideas that are not your own, to prevent committing academic plagiarism. But aside from preventing plagiarism, citing also allows you to demonstrate that you actually know the research area, that you have found all the relevant literature, read it and understood it, and can present its main weaknesses and strength. It also allows you to add authority to statements you make without using a lot of words, by just referring to a source that showed whatever you are stating or claiming. So citing is essential in academia, and most of you are probably familiar with the basic principles of citing. We just want to give you a quick introduction into the specifics of citing in English. And in English, the specific notation and practices for citing actually depend and differ. They depend on the publisher, for example, or also the field you're in. Yeah? So there are typically style manuals published by professional organizations or publishers that specify exactly how you should cite in publications for this publisher or in this field. This you should check, but if there's nothing prescribed by your university or a publisher, we will present practices that are widely accepted in the field of computer science and at most universities for referring to foreign content. Yeah? We distinguish that into direct quotes, that is reusing text from other sources literally, and it is typically distinguished between shorter direct quotes and longer direct quotes. The exact cutoff point depends on the style manual, but many define a short quote of having up to 40 words and longer quotes respectively more, and distinguish how to cite these two types of quotes within the text. For shorter quotes, the practice is typically to cite them directly within the text using the regular typeface you also use for your other main text, and enclose the repeated literal excerpt in quotation marks. For longer quotes, you do no longer use quotation marks, but put them into a separate block, which you visually set apart, for example, through indentation, italic font, or smaller font size. Generally accepted is also that if you change anything in the original text that you cite, you mark this. with square brackets. So any addition or alteration you mark with square brackets. You also mark omissions with square brackets and put the omitted part as 3 periods. Apart from that, you are also, or it's also good practice to mark errors in the original source with the word sic. Sic is a Latin word or Latin phrase referring to sic erat scriptum, which literally translates into thus was it written. So it is the accepted practice to not change errors, typos or grammatical errors in direct quotes, but rather mark that you recognized that it is an error with the word sic. And the last thing you should keep in mind, or the situation you can encounter in direct quotes, is direct quotes that already contain another quote. In this case, you should change the type of quotation marks used. For example, if the original text that you're quoting uses double quotation marks, these double quotation marks should become single quotation marks in your quote, whereas you use the double quotation marks to mark the end and beginning of your literal quote, of your short literal quote. And if you're on the opposite, using single quotation marks to mark the beginning and end of your short literal quote, then any quotation marks that are part of the original text would become double quotation marks. In any case, you would end your direct quote with a full reference meaning both the in-text citation to the source and a page number where in the source this direct quote can be found. Some examples. The easy case, an unaltered short quote. Please make it a habit for you to introduce the authors or to identify the authors in an introductory phrase, and not use this style, which you sometimes see also in publications to save space. This is no longer a full sentence, which is why many reviewers and also university teachers frown upon it, because this is no longer a proper English sentence. A proper English sentence contains a subject. So avoid this style, go rather for this style. And the literally repeated part is in this case rather small, namely referring to academic plagiarism as a cardinal sin, is put into quotation marks, and full reference, including the page number where in this source this quote can be found, is added at the end. If we change a direct quote, so in this case add an explanatory term, CPA for co-citation proximity analysis, or decide to change the case of this term from small case in the original text to uppercase, for example, to make it more consistent with other terms we use in our document, we have to mark that through square brackets. The same for omissions. So if we would leave out the word traditional, for example, in this original quote, we would have to mark this, and we would indicate errors that already existed in the original text. Let's say in this case a newspaper article that didn't write due to mitigate hardships. It wrote do mitigate, and we would indicate that we noticed this error in the original text with the Latin word sic in square brackets. A more complex example of a long direct quote, which we no longer put into quotation marks, but put as a visually different block, visually different because of the indentation here. We still mark alterations, in this case the adaptation to the third person singular, and omissions as usual, and we end our quote with the full reference including the page number. When there are direct quotes, there must be an opposite part, which are indirect quotes, and this refers to all quotes where you paraphrase the findings, ideas, views, statements that other authors made in their papers in your own words. Yeah? To do that, you again use an introductory sentence that makes it very clear that the following content is not your own. Yeah? And again, you would end an indirect quote with a reference depending on whether you refer to a piece of content that can be located at a certain point in a source. Then you would add a page number, just as with the direct quote. And if that's not possible, if you're, for example, paraphrasing the content of the entire paper, then you can also omit the page number and just state the source. Some examples again, paraphrasing one source, you start with the introductory phrase that identifies the authors, because this also makes clear the following content or the following view is not necessarily your own. Yeah? Then you paraphrase what the authors have said and end, in this case, with a full reference, because this statement can be found at a very particular place in the cited source. Of course, you can also sort of reflect and paraphrase a dominant view that is present in multiple sources. You could, for example, indicate that with an introductory phrase such as many researchers or as commonly found in the literature, then paraphrase the statement and refer to all the sources where this idea or this statement can be found. A special case in our area, computer science, is often that you would like to refer to code libraries, software tools, or data sets. Common practice to do that is often case just to state a URL to a website or the GitHub repository that contains this tool or data set in a footnote, unless some authors explicitly suggest to use another reference, namely a reference to a full academic publication, in which case you should really try and do that to also acknowledge the effort that the authors put into the tool or the data set. Okay, so much for this brief overview about the most important rules for citing sources in English. Let's move on to the next section of our tutorial, which will deal with managing academic literature. By managing academic literature, we mean storing and organizing both the bibliographic metadata as well as the actual documents and your annotations in these documents in a way that you can reuse them for different projects, or also just use them within a very comprehensive project such as a literature review. So we will present some useful tools and also general approaches to do that that we found helpful in our own research. Particularly, we want to present 3 tools, namely JabRef, Mendeley, and Zotero, as well as one general format, namely BibTeX, to you as part of the next slides. I think many of you might be already familiar with BibTeX. For those of you who aren't, just a very quick introduction. BibTeX is nothing else than a plain text file format that is intended to store the bibliographic metadata, so author, title, venue where it was published, and so on, for academic papers, so that you can cite it. Originally intended for LaTeX, so citing these items in LaTeX documents, but over time it developed into a platform-independent format that many applications across operating systems and word processors can process and use to actually exchange information. As I said, a BibTeX is a simple plain text file that follows a certain notational convention, and to mark it as a BibTeX file, it has to end in the file extension .bib. Here you see an example of a typical BibTeX entry in this case, of the type journal article, which you mark with @article, open curly braces at the beginning, and then you have these different fields. These fields depend on the item type that you enter, so title, volume, number, and so on. Yeah, so you mark all this, in this case, in curly braces. In other dialects of the BibTeX file format, there are also, for example, double quotes used. And then you can access it just with a regular text editor, or also with applications specializing on processing BibTeX entries and actually citing the items that you describe in those BibTeX files. The upsides of using BibTeX is it's sort of ubiquitous. So if there is a question how to share bibliographic data, then BibTeX is typically the first option that publishers or any other person goes to share bibliographic data. It is very easy to add new papers because the order doesn't matter. You just add such a block for the new item, for the new paper that you want to add to your file, and that's it. And it's, since it is a plain text format, ideal for versioning control, for example, to just manage using a Git repository. Yeah. The downside is BibTeX, being a plain text format, does not handle the actual documents. So typically PDF, you can insert links or directory specifications where your file that belongs to a certain BibTeX entry is located, but you can't sort of put that into this file format. Yeah? So you must manage it separately. Same for the annotations that you make within these full text documents. So where to get BibTeX data? There are many options. As I said, it's ubiquitous. If anything is offered, then it's typically BibTeX. Google Scholar is a typical source for BibTeX, although I want to caution you that for the reasons that I already explained earlier, the data quality is often quite low. Yeah? So if you still want to get BibTeX data from Google Scholar, you would follow this little icon here that you typically find in Google Scholar result listings. Then this second window would open and you could choose from different export formats that you want to have this metadata, in this case of this literature review in. We would choose BibTeX and would get this. But again, Google Scholar is using automated crawling and automated extraction of this BibTeX data from the documents that they find. There are often incomplete entries or even wrong entries in these BibTeX records. In this case, this article, I know since I'm one of the authors, doesn't have 112 pages. Yeah? Rather, this is the issue. Yeah? So be aware that if you use Google Scholar for obtaining bibliographic metadata, it's often incomplete or even inaccurate. However, Google Scholar makes it very convenient to use its service to find both publications and their BibTeX data by offering a Chrome extension that you can use to search any text that you highlight with one click as a Google Scholar query. Yeah? So you highlight any text, in this case on a website, and you click on this extension that you would install and then have as a little button in your bookmarks page, for example, and it would automatically search the text that you highlighted in Google Scholar, and you would easily be able to jump to these entries or also to cite them via this button here. Okay. Other, and in terms of data quality, much better options to obtain BibTeX data are, of course, the original publishers. Let's say, for example, ACM, which has its own digital library, or IEEE, which also has its own digital library containing all the papers, conference papers and journal papers published by this publisher, and typically also provide downloadable metadata as BibTeX and other formats for these records. Not a publisher, but a very authoritative source for obtaining metadata in BibTeX particularly is DBLP. It's a hub, it's a bibliographic hub for computer science publications that offers a very high data quality. So you can search for papers and they only offer the bibliographic metadata, not the paper itself. And you can even choose different forms like a condensed BibTeX format or a long BibTeX format with a crossref to the conference proceedings, for example, and so on. So a number of options to actually download high quality BibTeX data, definitely higher data quality than, for example, you find in Google Scholar. So I personally caution you not to use Google Scholar BibTeX data. Although it is convenient, I would highly recommend to do, a few more clicks and find the BibTeX data somewhere else where it has not been extracted automatically. One rather convenient option of doing that for formally published papers can be to use a service that is called DOI2Bib. Yeah? For those of you who are not familiar with the DOI or what a DOI is, a DOI is a digital object identifier. Yeah? A digital object identifier is something that typically publishers assign to formally published academic publications. It is an alphanumeric string, in our area typically starting with 10 dot to indicate some computer science or technological paper. And it goes on with both numbers and letters. What many people don't know is that, yes, this links to the location where you can get the actual data. So for publication, typically the full text, but very often this DOI also offers in the background a service to obtain very good metadata for this item that the DOI refers to. Yeah? So technically it works like this, that the publisher or the authority that assigned the DOI takes the metadata that this publisher has about the item and sends it to a third-party service which then stores the metadata and provides it upon request. Also, DOIs offer the option, like every valid DOI offers the option to also get a shorter version of it, comparable to a short URL, for example, which still has all the functionality of the long DOI. So, DOI2Bib now is nothing but a little web-based service that makes use of this metadata that is often associated with DOIs and provides a little front end that you can access, enter any valid DOI and download the metadata that may or may not be associated with it as a BibTeX entry. So definitely in 99.9% of the cases, higher data quality than, for example, from Google Scholar. Last option that works most of the time is if you find papers on institutional repositories or on authors' personal websites, they very often also offer BibTeX data for it. In many cases, this is quite high quality BibTeX data, but of course, it can differ. So some authors or some institutions also don't pay as much attention to curating their BibTeX metadata, and you might still end up with rather low quality BibTeX data. So my suggestion actually would be, whenever you have a DOI, try to use the DOI. If that is not the case, I would strongly suggest to do the extra clicks and go to either the publisher and check whether you can get a BibTeX data there, or go to DBLP and see whether they offer bibliographic metadata for the paper you're interested in. So much for BibTeX as such. Now, let's assume we have our metadata. How do we, how can we interact with it? How can we organize it? And I want to introduce a front end to BibTeX for you. So a front end application called JabRef. JabRef is an open source project that works entirely on this plain text BibTeX file. So not a database, for example, but just this one file, however large or small it is, but it offers you a lot of additional organizational and other functionality on top of this file. For example, this is the main view that you would see when you install this tool. It just shows you a sortable and filterable list, also searchable list of the entries in your BibTeX file. So you can sort it according to any field that is included in your BibTeX entries, or also search it, full text search that is actually quite capable, supports, for example, regular expressions, and so on. It also makes it a bit easier to edit your BibTeX entries. So you no longer have to edit it directly in the plain text, but for example, it offers you a nicely structured graphical user interface to easily edit certain fields, or if you still want, if you're familiar with that, you can still get a plain BibTeX view and edit your information there. Also, it offers a number of organizational features. So organizational features that are hard to obtain by just working with the plain text file, like grouping, assigning freely worded tags and storing them so they are stored in the BibTeX file themselves. Organizing, so bringing more structure to your BibTeX file this way. Yeah? So you could assign, for example, topic keywords or other tags, whatever you want. They will be stored in the BibTeX file, so they are also persistent. A very nice feature also is that JabRef allows you to view PDF annotations that are made with the standard PDF tools like comments and highlights as part of the user interface of JabRef. So if you link a file, a PDF file, and you can do that to your BibTeX entry, JabRef will actually insert a file link as part of the plain text BibTeX data, and it will also try to extract PDF annotations in this file and show them to you as part of the user interface. Aside from that, it offers some functionality to actually either find full text or also complete your metadata for certain records, like searching publisher websites or typical publication repositories such as arXiv, CiteSeerX, and so on. And it also allows you to use this DOI metadata service that I showed you earlier to complete BibTeX entries that you already obtained, but which might not have the best quality. So you can, if you already have a BibTeX entry and you have a DOI for this BibTeX entry, JabRef actually allows you to use that DOI, look up the metadata that the DOI service has associated with this entry and compare it in a sort of diff-like function, diff-like compare and merge function with the entry you already have to increase the data quality of the item you have in your library. It also, since it's working on the plaintext file, JabRef offers nice features for bulk editing entries in this BibTeX file, like getting rid of HTML, for example, or formatting certain special characters to be LaTeX safe, so in the specific LaTeX format, and some more. So this is very useful. In summary, the strong points in favor of JabRef are definitely it only needs a simple plain text BibTeX file, no matter how large it is or no matter how small it is. It offers some advanced features like full text search, bulk editing capabilities, lookup and completion features. It runs on Java, so it can also be installed on different operating systems and in a portable mode. So you do not necessarily have to install the client application on your system. It's open source and has a quite active community. On the downside, there is no web-based version of JabRef, so there's really just a client application, and you would need to have a computer running this application ready in order to add any literature and so on. You can't just go to the web and add literature there. It doesn't have any support for what you see is what you get, word processors like Microsoft Word or LibreOffice, because it is really focused on BibTeX and the original use of BibTeX, which is for LaTeX. Yeah, so no word processor support, also no browser plugins to automate the import of new items to your library. It also has very limited file handling. As I said, it only provides inserting links to certain files. It also does not allow you, although it shows PDF annotations, it does not allow you to open the PDF file and directly jump to the position of this particular annotation, which is a feature that other tools we will see in a bit offers. It also offers a collaborative editing mode. Although this editing, if you want to work collaboratively on the BibTeX file, has to use either Git or a shared SQL database. So there is functionality to actually convert the BibTeX file into a shared SQL database, and then you can work on that. But of course, this can cause conflicts and you would need to resolve them via the normal way, as for example, you would resolve conflicts in code repositories that you manage via Git. In summary, JabRef is a good tool to make interacting with BibTeX files easier. It has all the essential features you need, like completing, easier editing, and so on. It's definitely primarily intended for LaTeX users, not really suitable if you rather work with a graphical word processor like Microsoft Word or LibreOffice. The next tool I'm going to present is much more suited for this later use case that I just mentioned, namely Microsoft Word or LibreOffice users. It's called Mendeley. It's provided by the Elsevier publishing house, which also publishes academic publications. It is a tool that offers both a classical client application and a web-based system. So you can just go to a website, log in, and you will have your library independent of the computer you're using. So you have all your information also accessible online. It is a commercial tool that, however, offers a free version and 2 GB of free storage for PDF files and metadata. And the two, so the client and the web application, are synced automatically. Aside from that, you already see that it looks in its basic components very similar to JabRef or also to other tools. Namely, there's typically a central table that shows you all the items that you have in your library. It has organizing features like groups and in this case tags that you also saw for JabRef, and it has a third area for editing entries. So let's take a look at this in more detail. As I already said, you have organizing features, so you can create certain sub-collections within your larger library. You can tag, filter, and search your entries, and you can edit, if that's necessary, manually edit entries via a graphical editor. What is very nice about Mendeley is that it offers a built-in PDF viewer with the option to also annotate the PDFs. So the PDFs open directly within Mendeley, and you can annotate them, and these annotations are permanently stored together with your PDF file and also the bibliographic metadata. However, you have to be aware that this functionality is proprietary. So they are not using the standard Adobe PDF annotations that many other tools, many other PDF viewers and editors use, but they use their proprietary format, which can be a problem if you at one point in time decide to leave Mendeley and want to export your items, including the annotations. It is possible to export them, but the format in which it is exported is not very nice, so don't expect to have annotations that you can easily edit, for example, with another PDF viewer. A nice feature, though, is that Mendeley offers you a web importer. Yeah, so wherever you are, for example, on a publisher page, you can just open this little extension in your browser and automatically import items to your library. And if there is a full text that you can access using the library access, for example, at the moment, then if it's accessible, Mendeley will also import it automatically and link it to the entry in your bibliography. It also offers collaborative features, so you are able to create groups which are detached from your own personal library and can be used to share content with others. Of course, the others also have to have a Mendeley account to be included in the group. Moreover, it offers plugins for visual word processors like Microsoft Word and LibreOffice. So you install a little template here, and then you will have an add-on that will allow you to insert references directly from your Mendeley library. It also offers the option to change citation styles. For example, switch between the ACM and the IEEE citation styles, both for formatting in-text citations and the bibliography. It also offers a huge number of defined citation styles that you can just choose from and switch at the click of the button, which is also sort of the main use case, or not the main, but the must-have use case of reference managers, namely to be able to cite items and quickly switch the citation style. Mendeley supports an open standard called the citation style language, which actually allows you to edit, adapt, change, extend existing citation styles, so how in-text citations and your bibliography are formatted. For example, you may want to add a field that is typically not intended for an entry in the bibliography, like here, the DOI. Not every standard citation style, for example, the one of ACM, supports DOI, printing DOIs by default. One option to enable that would be to edit the original ACM style as I did in this example here, and add a DOI if it is present. So there is the option to both do that in an XML format or to go to a little web interface that allows you to edit the different components of a citation style interactively. It also has limited automated processing features like automatically renaming files that you add to your library. So specifying basic patterns like title, author, or journal, author, and so on. This is very useful. It also has a watch folder so that it automatically adds any item that you put into this folder, for example. But compared to the last tool that I will show you in a couple of minutes, these options are rather limited. So author, title, year, and journal are really the only components you can choose, for example, to rename files. BibTeX sync is possible using Mendeley, so it is not only suitable for use with LibreOffice or Microsoft Office, but of course also is a valid option for LaTeX users, because you can always export your Mendeley library as a BibTeX file, and it also offers you the option to do that automatically on any change in your library, so that you can keep your BibTeX file, which you use in your LaTeX word processor, up to date. In summary, Mendeley is definitely a mature, good tool that especially offers a very nice looking user interface, although it has, at least in my experience, some functional bugs like resizing bugs and reordering bugs that are a bit annoying. It also has a rather stubborn sync with its cloud version. So sometimes you delete certain entries in one version or the other, and it keeps syncing them back to your computer. So yeah, a couple of issues there. It has very excellent word processor plugins, so plugins for LibreOffice, Microsoft Office. It also supports interactive LaTeX or collaborative LaTeX editors like Overleaf very well. It has a decent import, from the web and also from other formats into the local client. It has solid BibTeX sync. It can handle files. It also offers bulk editing and DOI lookup and completions like we saw already for JabRef. That's all there. On the downside, it is a commercial tool. You have to keep that in mind. So your data is sort of closed away in this application, although there is a free version available. However, this may change in the future. It only offers proprietary PDF annotations that are not editable with other tools, although they are exportable as graphics basically within the PDF file. It has no option anymore. It used to have, but not anymore, to directly access your library as a SQLite database. That was eliminated in one of the recent versions. Now the database is encrypted and you can't access it anymore. As I said, already some syncing issues. Maybe they are fixed, but in my experience they were there. And yeah, it is also sort of error prone when importing, particularly from BibTeX. So the BibTeX import often results in wrong fields, inaccurate fields, and stuff like that. It also has some limitations or issues, better to say, so that not everything's working when you work with group libraries, and some UI bugs. So overall, I would say Mendeley is a solid tool for LaTeX users. It's quite good for what you see as what you get word processors, but you feel that it has a quite dogmatic way of how you should use this tool. You're not as free as you are with the last tool that I'm going to show you in a second, about how you would like the process of using this tool to be. It's definitely a closed world, proprietary, commercial tool, and you also see that in the way they handle their data, for example. So I often compare it to Apple. What it does very well, but what it does is quite limited to really the essential features, and you're sort of used to, or you're expected to use them in a certain way. And if you want to deviate it from that, it can get sort of restricting quite easily. Nevertheless, it's a very well supported, well maintained tool. If you just want to quickly use a reference manager, I think Mendeley might be a good choice, particularly for visual word processors like Microsoft Office and LibreOffice. Last tool I'm going to present to you is sort of the open source version of Mendeley. In fact, many of the features you will see are very similar, if not identical, to those of Mendeley. It also looks a lot like Mendeley. It's called Zotero. You can already see that the Zotero interface looks a lot like the Mendeley interface in terms of the division of the organizing panes, for example, so tags, groups, main view in terms of a table, and the entry editor. As Mendeley, it offers both a web-based version and a client. Sync works the same way, even offers more options for syncing. For example, not syncing or not always syncing the metadata and the files. You can also choose to only sync the metadata to the Zotero cloud version, but for example, handle your files via another cloud storage provider like Dropbox or OneDrive, or even a WebDAV server. That is particularly useful because the free web space, the free storage space that you get in the cloud-based version is less than for Mendeley. It's only 300 megabytes of free storage. So it can make sense to just sync, for example, the bibliographic metadata directly to Zotero, but maintain the files with a different cloud storage provider. Other than that, as I said, it's very similar to Mendeley, so I'm not going over this in too much detail. It has the same features for organizing, collections, tagging, filtering. It also offers the option to import and store PDF annotations together with the entries in your library via a plugin called Zotfile. So you see here, this item has both a PDF file attached, so this would be the PDF file, and in this PDF file are annotations which I extracted and can now see here in this panel where you otherwise would see the entry editor. What is nice about it is I can directly click on one of those annotations and jump directly to this position in the PDF file. So the PDF file would open and I land exactly at the position where I made this PDF annotation. Also, the PDF annotations correspond to the standard Adobe PDF annotation format that any PDF viewer supporting annotations can process, which is better, in my opinion, than the proprietary format of Mendeley, for example. Aside from that, it also offers a web importer, so most of the importing of items to your library will be automated by just discovering a certain item on the web and importing it, including the full text if it is accessible to your library. Same collaborative features, groups that you can share with others. Also, it offers plugins again for Microsoft Word, LibreOffice, and even Google Docs. Yeah, so you can insert your references there, and it also supports the citation style language, as we already saw for Mendeley. So you can choose from hundreds of predefined styles. For example, also those that work with Mendeley because it's the same technological standard. expressed in the format of the citation style language. So you can even use Mendeley styles in Zotero and vice versa. The same goes for adapting styles via the web-based style editor or the plain text file. You also have the feature of watching a certain folder for new items and importing them automatically. However, the automatic renaming and also organizing features of Zotero are much more feature-rich, offer much more possibilities for renaming than that of Mendeley. So you can basically use any field that you have within entries, within metadata entries for renaming, and you can even apply processing functions like shortening, uppercase, lowercase, and so on to this. So it's very feature-rich in terms of automatic renaming. It also offers very advanced bib. So you have great options to, for example, assign very sophisticated BibTeX keys to your entries automatically. This is supported via a plugin called Better BibTeX, and it also syncs to a local bib file, so you can use it in your LaTeX word processor. Same as Mendeley, it also supports collaborative LaTeX editors such as Overleaf. Beyond the classical use of reference managers, namely citing publications in academic documents, the Zotero community is very active, open source community development, and actually offers a lot of plugins and extensions for using data in Zotero for other use cases such as publication lists on web pages or any other form of publishing. So there's a huge number of plugins and extensions that work with the Zotero client or web library. So in summary, Zotero has a good functional UI that is quite similar to that of Mendeley, although not as visually sophisticated and pleasing maybe as Mendeley. It has good cloud support, good collaboration support that is definitely equal to Mendeley, if not better. It has the same excellent word processor plugins for Microsoft Word, LibreOffice, and even Google Docs. What is noteworthy, and I haven't showed that in detail, but it has a very excellent search capability, which comes in handy for large libraries. So it offers full Boolean search and even wildcard search. It offers good import plugins that work, for example, much better with BibTeX than Mendeley in my experience. It also offers import of metadata by DOI directly from the interface. And it has many excellent features for organizing, for using Mendeley data for other applications, for interoperability, for handling files and so on. It's too feature-rich to explain everything in detail, but it has really a lot of features. It's open source, free, community-driven with full access to all data. So yeah, your main library is actually a simple SQLite database that you can access, and also, since it's open source, all the methods working on the data are completely transparent. On the downside, there are two nice functionalities that are still missing in Zotero, which are, for example, available in JabRef and Mendeley, which is DOI-based data completion. So if I have a base record and I want to update it with high quality metadata I obtained from publishers, there is only a workaround available in Zotero right now. We are importing the entry again and then merging. There is no direct completion as we saw with Mendeley. Also, there's very limited bulk editing capabilities yet. There's a workaround for all of it, and there's also these features are also promised for near future versions, but as of now, it's not included in Zotero yet. And the UI, of course, could be maybe use a little visual overhaul. Also, which can be a little downside if you only look for a very simple tool to use with, to work with. Zotero is a bit more complicated just because it has so many features and options that although the base functionality is probably very easy to get to know, getting to know all the features has a slightly steeper learning curve than other tools. Still, my recommendation would really be if you are looking for a reference manager for more than one project in your study, and particularly for your thesis, I would totally recommend you to use Zotero because it's really an excellent feature-rich tool, feature-rich for both LaTeX and visual word processor users, and even many other applications like blogs, website owners, and so on. It's completely open, driven by a very active community, so it's really sort of a Linux-like spirit. They try to help you a lot and quickly and make even sort of corner case requests possible. It, in my opinion, combines the strength of both JabRef and Mendeley, and that's why I would really recommend you to use Zotero if you plan on writing more than one paper or doing more than one project with it. If you really just want to use it for a rather limited time, then maybe Mendeley might be easier to use for you. Okay, that sort of completes our tutorial. I just would like to briefly recapitulate the main points you should take away from the content we presented. So we first showed you how to use academic search engines and which good academic search engines are out there to find relevant literature for your project. Keep in mind, free versions are Google Scholar and Semantic Scholar. They work for sure. Proprietary academic search engines that you would have to check whether you have access include Web of Knowledge and Scopus. Very helpful tools for filtering qualitative papers is the cited by feature to see how many other researchers refer to the paper you are looking at, or to narrow down your search to filter by author, by venue, and so on. Also keep in mind to check references of papers you already identified as relevant for prior work. Regarding the efficient reading of papers, we introduced you to the 4-step approach consisting of filtering steps that should prevent you from reading entire papers for most of the papers that you read. And also we will provide with this video a material that tells you exactly the expected structure for scientific papers, which is useful to know, A, if you want to write an academic paper, and B, if you want to jump quickly to specific content in academic papers that you're reading. And last but not least, we showed you the conventions for citing academic literature in computer science. We recommended to use the all square bracket notation for doing so. Yeah, so you use square brackets both for actually indicating the reference, for marking alterations to direct quotes or omission in direct quotes, as well as marking errors. This is accepted at most universities. However, if your university imposes a certain style menu, it's worth checking whether they might expect another citing style, and particularly if you publish a paper or intend to publish a paper, check the style menu of the publisher or the association you want to publish this with. And aside from how to cite, we also showed you good tools that make it easier for you to manage your literature and eventually cite your literature. Many of them are interoperable via the BibTeX format, and the one we showed you include JabRef, which is just a visual front end to the BibTeX file, as well as Mendeley and Zotero, which are more complex, feature-rich tools that are very similar, whereas Zotero is the tool that offers a wider range of features. So it is our recommendation, but yeah, maybe you check out both of them because they are very similar in the features. Just Zotero offers you more options in terms of features, use cases, and also, exporting and importing data than Mendeley. Okay, this concludes our tutorial. One last tip: you find a lot and more of this information and also more extensive information in our wiki, which you can use for free. Just a sign up is required, but it's completely free and without obligation. So yeah, go to perl.org/gib-wiki or scan this QR code and you will be directed to it and can sign up for it. Okay, thank you very much for watching, and I hope this information will be helpful for you.